So this talk's called Let Me Secure That For You. I did a trial run of this talk at work and they were like, that's not what we do at our company, you should really make that clear. So this is the slide that makes it clear that this is stuff that I've been playing around with myself, not stuff that I do at Red Shield. We do something similar, which I guess is why we wanted to make sure there's no confusion. So we shield people's security issues, I guess in a similar way to this talk. But at Red Shield we don't use ModSecurity or Nodejs, and we wrap a service around this. So yeah, I'm trying really hard not to do a sales pitch while also making it clear that this is not what my company does. So when I was playing around with the tech behind this talk, I was thinking, I've worked in security teams before for companies, I've done pen testing before, I've been a developer before. Is there another way to fix security issues, and what would that look like? So that's what this talk is about. It's about the idea of virtual patching. But let's go back to building a secure web app. So it all starts with this. It's the customer with a need. And they're like, I really want to be able to do something, make to-do lists, or something like that. And you're like, cool, let's spin up a dev team and have an SDLC and produce this software that creates something that the customer needs. And like, we can put that on a web server and publish our app. And then the customer can use it, and that's awesome. But is that a secure web app? Well, then you're like, well, it's in production, so we really should have like this production network. We should put a firewall in front of it because that's what everyone does. And then, PCI says we need a web app firewall, and we want a proxy for outbound traffic. And we need AV because of PCI, and we need like some sort of configuration agent running on the boxes to make sure they meet standards. And then we need to worry about detecting intrusion, so we stick an IADS in there, and we need to worry about data loss and exfiltration of data, so we put DLP in there. Then we need to manage the users that can access the environment, so we have this identity access system. And then all these things produce logs, so we need to put them into a SIEM. And then, well, hang on, maybe the software we're putting into that environment isn't secure. We've just made the environment like rock solid. So we better train our developers, and we better review the designs before we build the software, and we better threat model and make sure that we've considered all possible threats. And maybe we can run our code through a static analysis tool, and it'll find like Java classes and stuff like that. That worked really well for struts. A tool did find an issue in struts, but it had been there for like years and years and years. Or maybe we can use this dynamic analysis security testing where it'll run our app in a browser and click on links and futz around with JavaScript and try and discover issues like that. Or the newfangled interactive application security testing, which is when you like instrument the app and you test it dynamically, and then you figure out if all the code paths have been exercised. And then maybe you actually have a team that does security testing in your SDLC, and you even embed one of the Gartner exciting new things called runtime application self-protection into your app, and it can try and detect attacks as they happen. And now maybe we're secure, and we've got a secure web app. Oh, but we need to put some processes around this because, we've got all these things that we're just chucking into our environment, so we need to harden our operating systems and manage patches and make sure we've got everything up to date, and we've got a baseline configuration. We need to modify for file tampering on the server, and we need to make sure we govern identities and make sure that there's some process to make sure that when people leave, they get decommissioned. Configuration management processes, change control, cloud workflow protection. We need to automate our app releases. We've got all these logs that we're collecting. Now we need to make sure we've got a process for monitoring them. We need to have some policies in place. We need to have some standard operating procedures. Maybe then our app is secure, but we need to get it externally validated, right? So we run some vulnerability scans against this. We have a third party come in and do some configuration reviews. We pay $2,000 a day to get someone to penetration test it. And then we also get attacks coming in. And now we're secure. So we've built it securely. We're hosting it securely. We're verifying it's secure by throwing processes up the wazoo and getting third parties in. The approximate cost for all of this to secure our to-do list application, it's probably, I don't know. There's some security vendors that are going to be involved in that. But is this like really helping us make a secure web app? Hey, my green tick is black. Like, we've built the secure web app, we've got it out of the door, we've tested it, it's all really secure right now. But you know, everything changes. We build new features, new vulnerabilities come out, environments change, people change. And what happens if there's bugs in our software? How do we react to them? Can we fix them? Well, if they're really simple bugs, hopefully a web app firewall will find Crosssite scripting or SQL injection input and block it. Or maybe the RAS code that's embedded in your app might catch some attacks. But what if there's business logic bugs? What if you've actually just come up with a dumb idea? You just haven't thought of stuff. Or, like if you go to page 1 and enter something, go to page 3 and toggle a box, go to page 7 and do something bad happens. How do you fix that quickly? Well, then you've got to hope you can deploy software quickly, right? Because you've got to go through that whole SDLC to make your patch. And hopefully you've got some good automation so you can deploy like a gold build that you know hasn't been tampered with, so that you can fix your security issues in your app as quickly as possible. But that costs a lot of money because unfortunately all of those people involved in that process have to do stuff. So you have to divert them from whatever new and shiny team, the thing the product team's working on. They have to branch the code, write the fixes, merge it back in, build it, test it, go through release management, change review, and then release it. Well, that would be your normal process, but maybe you shortcut that process because it's an emergency, in which point, what was the point of those processes? I don't know. You might have an expedited process, but it's still costing you time, the time between the issue being discovered and you actually getting the code released. If you're a really awesome company, that time might be measured in hours or days, but most companies struggle with that. And you might not even have the source code for the app that has the vulnerability in it. It might be legacy, it might be third party, the people might have moved on that built it, you don't understand it. And so you might not even be able to deploy an app quickly to fix security issues. And so we've all probably been in this situation. Maybe not just security issues, but just general bugs. I've done the thing where I didn't have the source code at the version that we were released, but luckily it was a .NET app, so I could just copy the app back off the production server, decompile the DLL, write the IL to change it, recompile it, and upload it back to the web server. But you really don't want to be in that situation, right? So maybe there's some better way of doing it. Maybe there's some way where we can patch our security issues without touching the underlying website. And that's this idea of virtual patching. So what I'm suggesting is that maybe we take the web application firewall out and replace it with a more capable layer, something that does more than just a web application firewall. And I've called this "Let me secure that for you," because you can drop something in there where you can sit in front of a vulnerable website and secure it for people. So what's virtual patching? Well, virtual patching is the aim is to prevent the exploit of a vulnerability that you know about. This concept was first used, I think, by IDS vendors, which are like, we've got all these signatures and we can detect threats coming in your network traffic. Maybe we can just drop stuff that's threats and like patch your network for you. And it's been adopted by, I guess, the Appsec web industry as well. It's an agile security approach. I'm using the word agile to mean fast, as opposed to meaning good quality. But it's something that you can do quickly. I think most people use it in the second way. In my way. You can do things quickly while you're waiting for teams to do stuff in the software development, and especially if you've got a security team and a product team, like I've had in previous jobs, where the security team's sitting there fretting while the product team is manically trying to fix a security issue. This gives the security team something to do, and you can potentially block the vulnerability in advance. So this is the virtual patching approach that I guess I'm advocating here. And the approach I suggest is first you try and understand how to exploit the security issue. So pen test reports come in, or HackerOne report through bug bounty or whatever. You need to figure out how to recreate the issue and how to exploit it. So that might mean, using Burp to replay requests and fiddle with them. There's, I guess, 100 ways you can recreate the issue. Could just be a set of steps. But once you've figured out how to exploit the issue, then you can figure out how to patch it. And the temptation is to go, this one page has cross-site scripting, let's block the angle bracket from every page in our site. What I'm suggesting here is that you only patch actual known vulnerabilities or weaknesses. I think the thing where people go wrong is by getting too broad and trying to patch everything, every threat that might ever happen to them. Yeah, I guess that's a contentious thing to say. But if you can if you focus on the things that you know are absolutely bad, then the changes you make are unlikely to affect regular users. And where web application firewalls get a bad rep is that WAFs often block legitimate traffic. And so, a user's using your app and they'll get a blocking page and they'll go, what is this? And then they'll tell their manager, who is the CEO, and he comes over and says, you blocked a sale that was worth $17, turn the WAF off. And then the whole company has no WAF anymore, and then you fail your PCI audit, and then bad things happen. I don't know what happens if you fail your PCI audit. Probably consultants get money. So this idea of virtual patching is to try and patch the exact issue that you have a defined known exploit or a defined known weakness in your application, and avoid things that cause issues like false positives, large block lists across your whole site. Okay, I think I've laboured that point enough. There's different things you can do in a web application if you know there's an issue. You could block. So if you want to be ugly, user experience, just put up a block page that says, you're naughty, don't go there. If a regular user is never going to see that, then you don't even need to involve your UI/UX team. Only attackers are ever going to see that page. Who's seen that Akamai block page, or the Cloudflare block page? Yeah, for some reason I see them all the time. I don't know what I'm doing when I browse the internet. You could redirect the user to an error page. You could transform the request or response. So transforming the request might take away the dangerous stuff. Transforming the response might hide some information you don't want the user to see. You can validate. I quite like this approach, although it's more work, is if the application already has validation messages in it, you could validate the incoming input and then stick more messages back in there to say, you're trying to use a script tag for your username. We don't allow that. And this, I guess, is not an alternative. Probably you need to alert so that you know that the thing you've done is working and that you're under attack. So here's the architecture. I will let you dwell on this long enough for you to go, oh my God, that said WAF on it. I'm freaking out. And here's some real quotes that I made up about WAFs. And I think you've probably all heard things like this. Users hate them. Developers hate them because it slows down their release process. And sysadmins hate them because they're getting these requests to tune things. And the security team hates the WAF because it doesn't really stop real attacks. It doesn't stop business logic flaws from being exploited. You have this WAF that you spend $100,000 on, and then you get your first pen test, and the pen tester said, well, I changed the word script to have a capital S, and then, the JavaScript ran. And of course, decent WAFs, that wouldn't work, but it's a bit of a facetious example. But, they can evade WAFs because they're awesome, and they get paid more. So just to recap, why you shouldn't freak out that you saw the word WAF on that previous slide is the yellow bit there, which is that we only want to patch known vulnerabilities or weaknesses. We're not going to block every page on the site. if someone enters something. There's no chance of false positives on any other page on the site except the one with the issue, and we're going to be really careful about it. So the next step is to pause to demo a vulnerable website. I'm going to just quickly tell you how the internet works. So on the internet, there's this concept of people and this concept of servers. And requests go to the server and responses go back to the people. Cool. Man, everyone looks like they already knew that. Okay, so we're sticking our thing in the middle here. And so the requests are going through our thing, and then they're going to the server. So we get a chance to look at them on the way past, and on the way back we do the same thing. Cool. I don't really think you're silly. I just thought it would be funny if I did that. So the demo site. So of course every demo needs a website. So this is my website. This is called 0 Days. This is where you can go to buy your 0 days. And this is a local one because I got the feeling that the internet was a little bit flaky here because I couldn't get to Twitter. So it's running on a weird port. So basically how this site works is it's got a shopping cart. You can buy like 2 ghost stripped command execution vulnerabilities for $9.74, and you know what else can we buy? There's no Solaris bugs. Oh, there's no Solaris anymore. Trend Micro, and then you know it's got a shopping cart. So you go to the second step, and then you laboriously type in where you live. Hey, New Zealand, I should change that. Oh no. Never mind. So you enter credit card details. Here's one that I happen to know. Don't screenshot it. What? Cool. No, I don't. Why do you keep asking me? Oh crap! I wasn't logged in. Hang on. There was a bug with the URL there, so I'll just log in. Okay, so I'm going to log in as admin, just so I can show you some other functions as well. I have to skip through that shopping cart again. Hey, vulnerability number 1. It's remembered my credit card number and displayed it to me. Okay, so you get to the end, and you've paid for your stuff, and you place your order, and then you can view your order. So it's a very simple, I mean, you've probably used websites exactly like this to do things like buy things on the internet. So you've probably seen this before. Other things that happen on this site, you can add comments like, this is a great vulnerability. You can search, so you can search for all the ghost script vulnerabilities. Oh, there's only one. And we saw that screen where you could see your previous orders and click on them. But the administrator also has some extra features. So when I'm logged in as an admin, I can go to Purgatory, which is where you purge the database. I'm not going to do that mid-demo because that won't go well. But you can also go and view all current orders in the database. So that's the site. Pretty sophisticated. The styling, I think, is particularly great, which I think is basically like theme 1 from Bootstrap. But yeah, cool. I spent lots of money on this talk. So vulnerabilities. So let's look at what kind of issues there are in this site. Well, oh no, let's do it as a scenario story-based approach. So you're really excited about this website. You've just got into the security community and security industry, and you're going to start selling vulnerabilities. You're like, oh, we should get a pen test. And so you find a pen testing company, and you go, hey, can you guys generate a report for us for $20,000? And they're like, cool, yep, here's some stuff we prepared earlier. Page 1's not looking good because the table of contents splits across 2 pages. And then you get this executive summary, and you're like, man, I hope red's a good color. And you find out that there's security features, security issues all over your website, and they've put screenshots in, and you're like, yep, this is totally worth $20,000. Man, I'm really bagging on security companies today. Lucky I don't work for one. So we don't do pen tests, so I guess that's okay. So vulnerabilities. So the vulnerabilities that were found in that site. So if we log out, turns out those admin URLs that we saw, you can just type that in using the power of the keyboard and get to the administrative unit interfaces. So that's not good. In the shopping cart, if you don't want to pay $245, but you'd rather pay negative $1,073, you can enter negative quantities. Other issues, so the search box here, I mean, the first thing you do when you see a search box when you're a penetration tester is you try and put a single quote in and see if you get an error message. And luckily you do. So then you can go and enter the magic SQL injection test script of single quote or 1 = 1 and get the whole database back. And so I mean, it's not part of this demo, but just trust me that you can point SQL map at this site and it will download this table, every other table in the database, every other database, and let you like drop tables, drop databases and everything through that one text box. It's pretty cool. What else is wrong with this site? Oh, basically everything is wrong. So let's sign up for a new account. Password. Oh yeah, password. Cool. No. So yeah, if you add a comment with a script tag in it, also the canonical alert 1, then 1 pops up. So that's obviously bad. And there's a cross-site request forgery issue as well, which means that, you know, if you happen to be logged into this website but you're browsing cat pictures somewhere else on the internet, the cat picture site can add comments against items. I won't demo that because I don't have the page open. Cool. So this website is pretty broken. And obviously I'm doing this all on purpose, but all of these issues are very common ones that you'll see in lots of websites once you go to look at your own websites that you have permission to look at. So it's not too unrealistic. Okay, so there's a list of the ones I just showed you were mostly from that left-hand category. We'll look at the business logic ones a bit later. So let's talk a little bit more about our architecture. So who's heard of ModSecurity? Hands. Cool. So ModSecurity is an open source web application firewall. Talk about that a little bit more in a sec. The OWASP core rule set is a bunch of signatures that you can use in ModSecurity to detect a whole bunch of attacks. And Nodejs is just a nice programming environment which is quite efficient for sort of streaming manipulation of stuff. It's an event-based kind of event-driven environment. And I chucked Redis in there because I want to store state. Redis is kind of like in-memory database. I'm using Docker for my demos, so just because Docker's kind of a little bit freaky, I'll just cover that in 60 seconds. So the way Docker works is you have containers, and you can run your application in a container, and it's like a kind of a cut-down operating system that's just running your app and nothing else. So there's a OWASP ModSecurity official Docker image. It's based on Fedora. So I guess it was inherited. I can't remember if that's the right word. From that to make my own one with my customizations. There's a Node one which is based on Linux Alpine. So I've made my own one of those. And there's a Redis one based on Debian. So yeah, for the purposes of this demo, I'll be running 3 different versions of Linux on my MacBook. And because Docker is awesome, you're supposed to think, yeah, that's a good idea. Cool. So I'll show you the setup. So the first thing I want to show you is just something that I think is really funny. So in this left-hand tab is Apache, and I've just got all the logs spitting out on the console. Did you know that if you run Apache in the foreground and you resize your window, then Apache shuts down gracefully? because they're using reusing this signal window change for something else because they never run a GUI, and so if they ever get a window change signal, then it shuts down. Yeah. Anyway, so that's really annoying, and that's probably going to happen during this talk. So that was just an explanation of that. So so I'll just start that up again. So basically, I've got Apache running in one tab, Node running in another tab, Redis running here, and I'm just outputting all the commands that happen on it. As for what the code looks like, this is the Docker file for my Apache setup. So I'm basically saying, using the OWASP ModSecurity image as my base, say the right words, I just want to install a couple of things and then copy my content onto it. And my content's basically an Apache configuration file, which is this guy, and then some ModSecurity stuff. Node is pretty similar. I've got a Docker file which says, starting from the base of the Node Alpine's image, npm install a bunch of packages on it, copy my application to it, and run. And I don't need to show you Redis because I'm not customizing that. Cool. And so when that all kind of sits together, I get my own version of the web application sitting on top of them all, which is called Let Me Secure That For You. And so the way you can tell is the broken one has days and the other one has fixed. But it's the exact same website running those layers. So when I refresh this, stuff's happening in Apache and Node. Okay, so I'll switch back to the slides. Cool, help yourself to my lollies. Yeah, great idea. So I said I'd come back to ModSecurity. Originally, ModSecurity was a module for Apache, which was written by Ivan Ristic, I believe, was the first contributor to it. And basically it plugs in like other Apache modules do, and it inspects requests and responses as they go through your web server. The kind of official stable version of it also runs in IIS, which is the Microsoft web server, and Nginx, which is another Unix one. I found the Nginx one to be a bit unstable, so I'm just kind of using the vanilla Apache install. There's a new version of ModSecurity called version 3, which has been rewritten to be more modularized. The old one was very Apache specific. The new one is more like a library, and then you put a connector in your web server that talks to the library and says, here's the request, is it good? Here's the response, is it good? That's not feature complete yet, but it's a release candidate. Out of the box, ModSecurity is a pretty safe thing to install on a web server. The default configuration is detection-only mode, which you could read if the pixels are bigger. And that basically doesn't block any traffic or do anything bad. And actually, the default ModSecurity configuration doesn't really do anything at all. It's kind of empty of configuration. So it's pretty safe to drop it in and turn it on. Cool. There's a good book called the ModSecurity Handbook that just got released last month or the month before, which will introduce you to ModSecurity and kind of teach you how it works. I'm not here to tell you that ModSecurity is the most easy thing to use, but don't let that put you off. It is free. Yeah. So if you want to use ModSecurity, the typical thing you want to do is put some rules on it to block traffic or to detect attacks. The OWASP ModSecurity core rule set is an OWASP project, which I think there's some companies contribute to it and some individuals, and it has rule sets for a bunch of common web attacks, so SQL injection and Crosssite scripting and a bunch of other ones. They've tried really hard to make it so it doesn't cause any false positives, but my approach is I want no false positives, not just a low chance of false positives. So I don't want to use ModSecurity's core rule set across my entire website. I only want to use it in the exact places there's issues. Just because it's kind of hard to understand, I thought I'd add this slide. So the core rule set has a configuration file. It has a bunch of different rules. There's ones that look at requests, ones that look at responses, and the rules are kind of named, the files are named according to the type of attack. And then as the request is going through it, sort of gathers up the score of how bad it is. And then there's some evaluation steps where that score is run against what you think is good, or what your threshold is. Cool. So how do ModSecurity work? Well, it's pretty fugly, but this is how it looks. So you have a sec rule. It has 3 arguments, the last one being optional. First argument, variables, operator, and then some action. So the variable, that's basically something that you can inspect. So request file name being like the URI of the request, the path of the request, or things like cookies or headers or info. The actions that you can do on it, you can do regular expression kind of checks, or string equality, or does it contain something, or greater than or less than. So that kind of makes sense. It's a strange syntax, which is caused by being in Apache config files, where you don't get much control over how your syntax is. And then you put a slash to say I'm going to continue this on the next line. And then you have to put an ID for every one of your rules, and it has to be different. So number, then you have a phase, which is which part of processing does this rule run on. Headers, request headers and body, response headers and body, or the logging phase. You say what you want to happen if this rule passes. So currently this says if the file name matches /order/details, deny the request. Then you have text transformation, which is to try and make sure people can't get past it. And then you have some logging. So that's the simplest kind of rule you'll ever see in ModSecurity. So like I said, it's a bit fugly. But it does kind of make sense once you've read a 400-page book. The next thing about ModSecurity is that if you want to combine rules, so you want to say, I'm looking for P equals test1 and Q equals test2, then you chain them together using the chain keyword. So that's you AND things together. And you can also do flow control by doing magic go-tos in your code. You basically put a string saying skip after else, and then the execution jumps to there and there. Yeah, so no one would ever call that a programming language. I don't know if it's Turing complete. I think it'll make Turing completely crazy, but yeah. So so that was really ugly. But that's ModSecurity. So I'm going to give you a demo of the ModSecurity part of the vulnerable website. So the first thing I think I did was going to an admin URL. So what we want to do here is we want to block the URL admin/orders so that people can't go to it, because otherwise they can see everybody's orders, and that would be bad. So the way I structure my stuff is I have this spreadsheet with all the security issues on it, where they're all numbered, and I just label the fixes according to the number of the issue. So this is basically that same rule you saw. If the file name begins with admin, then do some stuff. I'm just doing a little bit of extra stuff here because I keep track of who the user is. And then if it's not the right user, then I block them. So I kind of don't really want to get into the syntax of all of these rules that much, because the talk will get even more dull. But what the result of that is now if you go to that URL, you get the blocking page. So there's the pictorial representation of that. Reject. So the parameter thing, so actually I won't switch back to code, I'll just do this from the slides. This one is a regular expression check that says only allow one or more digits, which means the minus symbol will get blocked if it's in there. You might be saying that's not a valid way to match a number. Well, if it's got decimal points and stuff like that. And that's another weakness of ModSecurity, is that it's hard to validate data types in it. Cross-site scripting, I'll show you how this works. I want to reject cross-site scripting text only in the comment parameter on that one URL where my pen test report said there's cross-site scripting. Now, if I want to detect cross-site scripting using a regular expression, the regular expression would look something like this. That's kind of scary. And the core rule set project has compiled this, and I think they use code to generate the regular expression because it's too hard to manually enter. So basically the point of this slide is to say you don't want to do this yourself. And that's really why I wanted to use ModSecurity, because I want to take someone else's way of detecting XSS input into my application and use that to block the input. I don't want to figure this out myself, because I would never have known that if there was a DOM into document something late change, then that could be malicious JavaScript. So what this cross-site scripting, so basically I want to use the core rule set. So I've written up this stuff. I'll post the slides if you're interested. But what you have to do if you want to use just parts of the core rule set is you have to, I called it the DIY approach. I'm pretty funny. Is you have to load the core rule set, then you have to turn it all off, and then you have to say only use it for the search term argument, and then only on my page. So if you're thinking that configuration is really horrible, it's because that configuration is really horrible and you're not alone. But that's currently the only way you can do that. So now with my website, let's go back. So in the fixed version of it, if I try and add something to the shopping cart, no, not shopping cart. If I try to add a comment, oh, go away. Who did that? Go to a different one. So now this is going to detect XSS being entered and block. So that's good. But if I took this script and did it somewhere else where I know it's safe for people to enter angle brackets, it's not going to get blocked. And I guess that's the difference between the blanket block everything on my whole website, because I've worked on apps where we've tried to do that, and it turns out people use, select and into and union in regular English. And so if you're just blocking based on phrases, then select credit union located somewhere in America can't use your application. And they get grumpy and they raise a support ticket. So what else? Oh, I was talking about SQL injection. So it's the same kind of approach for the SQL injection one. Hey, it's lucky it's in my history. So now it blocks, and cross-site request forgery is a bit harder to protect against than ModSecurity. So I'll just explain it without just let your eyes unfocus. Don't focus, because otherwise you will go blind. So basically here, I generate a cookie, I send it to the user, I hash it, I then append some JavaScript to every page so that every form that gets submitted has to have the same matching value as that I put in the cookie, and then I check that it comes in and it's matching. So that's basically this double submit cross-site request forgery pattern, token pattern, or something like that. And it's really fugly. Okay, so I'm not really winning you over here. I can feel the mood of the room. And I'm not dumb. Like, I don't really understand many social interaction cues, but I know that you're all turned off right now. So we're just going to race on past, and we're going to pretend this never happened. So ModSecurity also uses some other ways of detecting cross-site scripting and SQL injection. I just wanted to point them out because I think it's really clever. So the regular expression is ugly, and there's this like formal proof that for any regular expression, you can either get around it with a query that it misses, or it'll block something that it shouldn't. And I didn't read the formal proof. I just read someone saying that there was a formal proof, and as far as I'm concerned, the internet never lies. So what this guy's done, and I should have written his name down because it would be much more polite, is he's made this library called libinjection, and instead of doing a regular expression-based thing, it takes the text that someone enters and it parses it as if it was a fragment of JavaScript or SQL, looking for like operators and keywords and arguments. And if it's a valid fragment of SQL, it goes, someone's trying to enter SQL because they said select star from blah. But if they just said from star select, that's fine, we'll let them do it because that's not valid SQL. So that's quite a promising approach. Cool. So another thing to do with ModSecurity is just edit stuff on the way through, so you can alter the headers of the query. So after all this, why do I suggest you use ModSecurity? It doesn't have the word free on there, does it? That's a really good reason. The reason I think ModSecurity is still good despite its configuration complexity is because it's actually quite good at detecting cross-site scripting and SQL injection if using that core rule set, even though it's a little bit hard to configure it. It's quite efficient, like it sits in a web server and runs really fast. Simple stuff is relatively easy. Complicated stuff is relatively impossible. But there's some limitations, like I only really want to use it for simple stuff, blocking URLs, editing headers, SQL injection, cross-site scripting. But it doesn't understand the state of my application. And the more complicated vulnerabilities in apps, you need to understand how the app works. You know, like the user has gone here, they've logged in as this person, they've gone to that page, they've clicked this, they can see this, they're not supposed to see that thing. So we need a system that can keep track of state. We need to be able to manipulate the response, to remove credit card numbers, to add text. So say someone enters a thing and you want to say, that can't be a negative number. You don't really want to have a blocking page. You just want to insert some validation message in the current page, edit the HTML. ModSecurity is quite limited in that, daunting. It is extendable via Lua, but there's not many examples of that on the internet. And I guess another limitation of ModSecurity is there's not many examples on the internet. Like it's an open source project that's quite well known, but there's not a lot of current documentation about the current versions, which is why I recommended a book rather than a website, because that is current. Quick diversion. So if we wanted to keep track of the state of a web app, how would we do that? Well, there's a few different ways that regular web apps keep state. They keep it on the server. You'll keep track of the user and stuff in a database. You might use a session cookie that's tied to a server variable. You might use hidden fields, you might use URLs. You can do all these things when you're protecting your website. So if you want to stop people changing URLs, maybe you encrypt every URL that you give them or sign them so they can't change URL, because when your web server gets them, they haven't been signed or encrypted. Or maybe you encrypt stuff that you put in hidden fields. So this is where we get to how might you do this a bit more complicated stuff. So our web traffic's coming in, it's going through ModSecurity and we're blocking simple stuff. We're sending the traffic through Nodejs and we want to block more complicated stuff. The particular incantation and libraries that I've used are Redbird and Harmon. And if you install just these two node packages, you'll get 160 dependencies, which you can then security review, such as Node and its ecosystem. There's a little sequence diagram which I'll show you about how a proxy works. Instead of marveling at the new knowledge you have learned, Instead, I would like you to marvel at the animation used in the sequence diagram, because I spent more time on that than the diagram. So how does a proxy work? The browser sends a request, the proxy grabs it instead of it going to the web server. The proxy copies the request so that it can edit it and sends the edited version to the server. The server replies, the proxy edits the reply and sends it back to the browser. So how does it work in this node model? It's pretty much the same, except we put two handlers in the middle. The proxy sends a request to our set of request handlers. Each request handler can modify the request or send a different response. So that might be like, take out some input that's dangerous or add some headers or whatever. Gets sent to the web server, the modified one. The proxy sends it through our handlers to make sure that any changes we need to do on the way out have been done. And then the response gets sent to the browser. Cool. Actually, the animation really wasn't that great. It still took a really long time. So, yeah. Cool. Okay. It feels like I should have got more than one applause, but I'll take one. Cool. So, more complex vulnerabilities. What does that look like when you fix them in Node? So first, let's look at what the vulnerabilities are. So I'm logged in as the test user. I can view my orders. Oh, I have none. I better add one. Please hold caller. Whoa. There's multiple vulnerabilities in this website. Let's just focus on one at a time. Cool. So I can see my orders. The first thing that any user does when they see a URL with a number that's really small in it and go, what happens if I change the 8 to a 6? Oh, I can see Joe Bloggs' order. And you're like, oh, that's bad. So how would you fix this? Like, if you had access to the source code of the app, you'd do it through an authorization check that says, did the user raise this order? But you're in the security team, you don't have the source code of the app. You could keep a database of every order that users are allowed to access, but then, your app's already got that. So I guess you could query the original database. The way I'm doing it is when the My Orders page is loaded, I'm parsing the HTML and looking for details links and grabbing the ID off them. So 8 off this URL, and then when someone views the details, I'm checking to make sure that they use the number 8. So just to show that implemented, go away. So I'm logged in as the same guy, that's handy. So details page parsed, collected the number 8 and popped it into Redis. When someone clicks on the link, it looks up 8, and if they change it to some other ID, this is just redirecting them back to their own list of orders. So what does that look like when you write it in code? This is going to be where we vote on whether this code is better than ModSecurity. So, screen resolution. So, with Nodejs's proxy module, I'll post this source code. It's just basically scaffolding around existing libraries. You can basically say, on request, I want you to call these methods, and on response, I want you to call those methods. And so in my method here, let's look at the response because it's where I'm collecting the numbers. I need to go through and look at every href and grab the numbers out of them. So I'm getting all the href attributes of all the URLs. And there's this nice library for Node that does this in a streaming fashion, so it's high performance. You can use CSS selectors, and that's called Harmon and Trumpet, the libraries that do that. And then I'm shoving them into Redis, down the bottom somewhere. And then every time someone goes to order details, I'm looking up in Redis to see if the ID is in that list. And if it's not, I redirect the user. So this is kind of more like the code that you would write as opposed to declaring configuration. But it's in Node, so it's still kind of hard to understand because of JavaScript. So I'm going to skim now. So yeah, modifying the request and response is a lot easier in JavaScript than it is in ModSecurity, because JavaScript and DOM manipulation is something you're very used to doing. So another vulnerability in this site was that you could actually skip past the credit card payments screen and just submit orders without entering your credit card details. So that's happened in the real world as well. And so the code there just keeps track of which screens you've been through, and Redis like sets a visitor ID for you, keeps track of which screens you've been through, and then if you ever try to go to a subsequent step without doing the previous one, raises an error. Cool. HTML manipulation, I'll show you this because it's kind of nice. So credit card numbers, in my site, if I highlight that, is it easier or harder to read? Yeah, it's hard both ways. So in my site, there is input fields that have credit card numbers in them, and there's bits of text that display credit card numbers. And for PCI compliance reasons, and also because we're nice people, we don't want to display credit card numbers. So this is just showing that it's reasonably straightforward to do that. So you use a CSS style selector that you're probably used to with all the JavaScript libraries since jQuery, and then grab the attributes out of that thing that you've just selected and change the value from the credit card number it used to be to asterisks. And so the example of that working is when I look at my order here, it says received by credit card, but the old site used to say payment by credit card and then the card number. So that kind of HTML manipulation. So if you're a security team and you've got a framework like this sitting in front of your websites, you could modify the HTML relatively quickly. Cool. So business logic vulnerabilities tend to be the worst vulnerabilities that I've seen, both as a product security team person and as a pen tester. They're the ones where you really want to address them. So cross-site scripting is bad and stuff, but business logic things can often be worse. And so some other examples of things that we can do is, we can actually put a whole new workflow around setting passwords. So the website let me just type password as my password. Because we've got JavaScript sitting in front, we can look up a list of known vulnerable passwords from Troy Hunt or a dictionary of bad passwords, redirect the user when they log in and say, hey, you just logged in successfully, but did you know your password is a bit bad? All that sort of thing. Protect APIs where it's, you need to parse content. Basically, once you put a programming interface in front of your website, you can do anything in code that code can do. So why am I using Nodejs? Because it's fast and scalable, and the library I'm using is often used by Nodejs infrastructure to load balance. It's the Node proxy library. And I've put performant HTML manipulation, but I haven't verified that myself. But my understanding is because it's streaming manipulating the HTML rather than buffering it all, it's more faster. The limitations are asynchronous programming is hard and makes my head hurt because I'm an old school, brought up on basic kind of developer and events. And you're writing your own code, but you don't want to write stuff that ModSecurity does better, which means that you'll probably want to use this in conjunction with ModSecurity, and you'll be trying to decide which tool is the correct one. Damn, Felix is finished. I have to hurry up. So this is my summary section. So basically the aim of this talk was to show you that virtual patching is a thing. So it's a thing that your security team can do, or even your app team can do, to fix legacy code, to fix stuff that would take a while to get released to production, for all those other things we talked about. So it's something else you can stick in your tool belt. If you prepare the infrastructure in advance, you can react really quickly. And you can take it from, building something securely, hosting it securely, and verifying it's secure, to being able to react to vulnerabilities in the application logic, which none of these other things that you've bought actually help you do. Like, you've got all this crazy stuff for securing the network, but nothing that lets you react and change when your application is vulnerable. And so I think its reaction time is really useful. Just to recap, I think I've labored this enough. Like, only fixing the actual vulnerabilities, not applying blanket changes. Your management and your QA team shouldn't have to worry about the rest of the application breaking, because you've got if statements in there saying only this URL, this parameter. Just a reminder that this is not actually what I do at work, although it's kind of tangentially related. And sorry, not supposed to be a sales pitch. Cool. So that's the end of my talk. Hopefully that's given you some food for thought. I have got a website, LMSTFU, which stands for letmesecurethatforyou.com. I've started posting some of this stuff, and I'll post that source code. Really, the source code that I'm posting is just how to scaffold together other people's source code. So I'm not like hey, I've just released this open source project. It's more like, here's some configuration and scaffolding you can use to write your own code. So prepare to be underwhelmed when you see how simple it is. But hopefully that you'll take these ideas back and think about, how would you react if you're under attack? How would you react quickly? Cool. Thank you very much.